Hello everyone, welcome to my YouTube channel. Today I have picked isomorphic strings problem. It is an easy problem but it's very important problem because this problem belongs to topmost 150 important interview questions. So uh, let's first understand the problem. It says that we will be given two strings and then in these two strings, there is a criteria. The criteria says that these strings should be isomorphic. And what first isomorphic is? Isomorphic means that there is two strings given and they follow a similar pattern, and then the pattern is based on the mapping. Mapping means that if one string is getting mapped to other string, then at every occurrences of that string, only the mapped string should come. So if E is mapped to A, at any occurrence of A is going to occur in the other string. Similarly, you can see that G is occurring and D is occurring in the place of G. D. Let's take another example. Here foo is given. So ideally, if for F, B is being mapped, O, A is being mapped. Now, according to the criteria for O, only A should come, but since R has occurred, this is not an isomorphic string and it is a false. Like this is not an isomorphic string. And again, you can see and you can follow see the similar pattern in given examples. But what's important, here is one more thing to notice, that if F is mapped to B, O is mapped to A, then O is mapped to A only, and instead of O, R has occurred. That's why it isn't false. Now, if O is mapped to A, so we know that at any place A is it is coming in, it is getting mapped to O. So the mapping is not in a one-way direction, it is both ways. So if like now let's talk about the solution. So if I take the solution here, see, now since we are doing the mapping, we know that in this problem mapping is being done. So whenever mapping something, this sort of word comes, then we know that here hash map can be used. Now we can use the same example. You can see here E is mapped to A. So in our solution, we are going to use a map where we at every places, whenever if at any string, one string is mapped to other string. If you haven't seen my video, I have added in the shorts where I have mentioned that how we check the mapping. If a particular element is mapped, then we know that the mapping is there, and if it is not mapped, then we map it to the hash map. So similar way, we are going to check whether E is added to A. E is a part of map. So whenever E is going to come, we know that A is mapped to E. So for E, we are going to map A here. Now at any occurrence, we know that if G is not mapped, then we will check. If G is mapped, then we will check that whether G is mapped to D. And if G is not mapped at all, then we will add it to the map. So similar fashion we are going to follow in the solution only. And here, so this is going to be the case for fun mapping. Let me rephrase or reiterate whatever I have said. So in the first criteria, we are going to use map. And then for map, we are going to check whether the element is added, is whether the element is added to the map. If it is added to the map, then whether the mapping is correct. If it is added to the map, if it is not added to the map, check if the element is added to the map. If it is not added, then add it and map it to the correct string. Yes. And suppose that here we can see like this is one way mapping, but what, like this is the criteria to check whether we know that there is certainly a mapping is being done and there is no false case. But it is not going to be one way mapping. As you can see, let's not get confused with isomorphic strings first. We have already discussed that what is an isomorphic string. Isomorphic string is all about a proper format that is being given. Here it is, we have to check the mapping is correct or not. See, so both ways, and it has to be both ways, not one way. So it is like one is, if one string is being mapped to other, at any occurrence the same mapping is going to get followed. And now let's check the false case. What if, like, f is mapped to b, o is mapped to a. Now we know that at any place a is going to be mapped to o. Now let's see, r is mapped to o. Like, we know that O is mapped to A, so we have to check whether O is mapped to A, but we also have to check whether at any point if we are getting A is only should be mapped to O, and also if we are adding a new mapping, if a new mapping is being added, then we have to make sure that it is not a pair of some other mapping, or it is not already mapped to something else. Like in this case, you can see R is being mapped to O, or O is being mapped to R. So this is a wrong case. So how we are going to make sure this? We are going to make sure this, because for this case we have to take other map, separate map. So there are going to be like first to second map, like first to second string a map is going to be there, and also for second to first string a map has to be there. So the mapping is going to be done from the both the ends. So let's not waste our time and just code it first, and then we will further come to the explanation. So for checking the isomorphic string, we first check the whether, like, this is a very basic case that length should be equal. If the length is not equal, then we know that mapping is not going to be correct. So if the length is not equal, we have to return false. And now we are going to take the map. Also, there is one thing to notice here, that since we are given, and in the problem itself it is saying that it is going to be ASCII character. So here we can take an array of 256 characters, or like this can also be done using array. So I just wanted to let you know. So we are going to take maps, and then we are going to, so one loop is going to be fine. I should be less than length of the array. And now first we will see that whether mapping is being done, map from S to T. So whether S of I exists in the array, sorry, map. And also there is a map which checks that whether mapping is done from S to T and T to S. So mapping has to be done from both sides to check all the cases. So if it does not exist, then we will do proper mapping. We are going to map S of I to T of I. So the characters are going to get mapped properly. And suppose the mapping is already done. So this is the case when it is not added and we are going to add it to the map. So mapping is, if suppose there is one side mapping and other side mapping is not done. So like this, the O is already mapped to A, but now we also have to make sure, like in like this, at this time, in this case, suppose one way mapping is done and the other way mapping is not done. This can happen from any end, like A is being mapped to O, like we have to take both the ways. So suppose we can check whether first map is being first character is in the first string, one character is being mapped to other. But if the mapping is not correct from other end, so we have to check from in the both the maps that the mapping is correct or not. So suppose we take this, like in map S to T, if the mapping is not equals to T of I, like this mapping is not correct, then we have to return false. And similarly, the other way around, we also have to check. If this is not being, if the mapping is not correct, like in the string, then we know that it is not the correct one. And if array passes and all of these cases are like all of these cases are already being checked and no any gap has been found, then we know that it is true, like the string is isomorphic. Let's check the solution. So it is accepted, and let's submit it. Okay, so this has been accepted. Let's now first come to the summary, how we are going to, how we have done it. So we have used two hash maps to track the mapping of character from S to T and from T of S. So we have to ensure that the mapping is one-to-one and consistent in both directions. We can iterate through character by character, and then we have to check for at index, like for at every index for both of SFI and TFI. So if SFI is already mapped to a different character, then we have to return false. So as I already told that this can happen both the ways, that a mapping could be different in any map. So we have to make sure that in both of the strings, the mapping for both of the strings in both of the map, the mapping is correct. Otherwise, we can return false. And also the time complexity, since we are doing it in the one pass, then we know that it is going to be big O of n. And we have taken two maps, which is a constant space complexity, like 2 of, this is 2 of big O of n. So in the worst case, all characters are unique, and then it can extend up to big O of n size. So similarly, the problem is same, and then we can follow this way. So this is the big O of n approach, and this is a very important problem. Do try, everyone. Keep learning, keep coding. Thank you for watching.